On the 11th of June 2026, forecasters confirmed that El Niño had returned to the Pacific Ocean. El Niño is a natural warming of the surface water across the middle of the tropical Pacific, and that warm patch can move weather all over the world. This one is worth a closer look for a plain reason. A warming this size has happened before, but no one alive has watched it arrive on top of a planet already this warm. By the middle of June, that key stretch of ocean had climbed to about 3 degrees Fahrenheit above normal, and it was still rising. Forecasters expect it to grow stronger through the fall and to peak next winter, so the story is only beginning. If you like calm, steady reports like this one, you're welcome to subscribe and follow along. From here, the report follows the event in order, from the first quiet signs this spring to what it could mean for heat, rain, drought, fire, and storms in the months ahead. The announcement was short and calm. The National Oceanic and Atmospheric Administration, the United States agency that watches the ocean and the sky, said that El Niño had formed in the Pacific. With it came a notice called an El Niño Advisory. That notice carries a plain meaning. It is the agency's way of saying the warming is here now, not merely on the way, and that it is expected to stay for a while. There is a quieter notice that comes earlier, called a watch. A watch means the conditions look right for El Niño to form in the months ahead. An advisory is the next step up. It means forecasters have looked at the ocean and the air together and decided the event has arrived. Moving from one to the other is not a small thing. It is the moment the science stops saying maybe and starts saying yes. This matters because El Niño is one of the largest natural levers on the world's weather. A patch of warm water sitting along the equator may sound like a local event. It is not. When that patch warms, it changes where the rain falls, where the air rises, and where the great rivers of wind in the upper sky decide to go. Those changes reach places far from the Pacific. They touch farms in Africa, rivers in South America, and winters in North America. By the middle of June, the stretch of ocean that forecasters watch most closely had warmed to about 3 degrees Fahrenheit above its normal temperature. That may not sound like much. Spread across thousands of miles of ocean, it is an enormous amount of stored heat, and it was still climbing week by week. The warming had not yet stopped. It had not even slowed. El Niño is the warm side of a larger back and forth in the Pacific. Scientists call that larger pattern the El Niño Southern Oscillation. The ocean swings between a warm phase and a cool phase, and back to neither, on a loose rhythm of every 2 to 7 years. The last strong warm phase faded a couple of years ago, in the winter that ran from 2023 into 2024. Then the Pacific cooled for a short spell, settled into the middle for a time, and has now tipped warm again. What sets this turn apart is not the warming by itself. The Pacific has done this many times. What sets it apart is everything around it, which the rest of this report will come to in time. For now, the simple fact is the one worth holding. The warm phase is back. It is growing, and the agencies that track it are watching it closely. To understand why a warm patch of ocean can reach so far, it helps to start with the ocean itself, and with the winds that usually keep that warm water in its place. Picture the tropical Pacific as a long bathtub lying along the equator, stretching from the coast of South America all the way to Indonesia. In a normal year, steady winds blow across the top of that tub from east to west. These are the trade winds. They have blown the same way for as long as people have sailed, and they do a quiet, important job. They push the warm surface water toward the west, piling it up near Asia and Australia. Because the warm water gets pushed west, the eastern side of the Pacific near South America stays cooler. Cold water rises there from below to take the place of the water that blew away. So in a normal year, the western Pacific is warm and rainy, and the eastern Pacific is cooler and drier. That is the balance. The winds and the water hold each other in place. El Niño begins when the trade winds weaken. Sometimes they fade, sometimes they even turn and blow the other way for a while. When the push from the wind lets up, the warm water that was piled in the west starts to slide back east, spreading across the middle of the ocean. The cool water in the east stops rising as strongly. The whole surface of the tropical Pacific grows warmer in the center and the east. That warm tongue of water is the heart of El Niño. Warm water feeds the air above it. Where the ocean is warm, the air rises, clouds build, and rain follows. So as the warm water shifts east, the rain shifts with it. Storms that once gathered over Indonesia begin to gather over open ocean instead. Places that counted on that rain go dry, and places that were dry can turn wet. This is the part that carries El Niño around the world. The rising air over the warm water does not just make local rain. It changes the path of the high winds far above the surface. Those winds steer storms across whole continents, move where the air rises in the tropical Pacific, and you nudge the weather thousands of miles away. One more piece makes the warm phase real. The ocean and the air have to agree. The water can warm on its own for a while, but unless the winds and the rain respond, it does not become a true El Niño. This time the air has begun to play along, which is part of why forecasters were willing to make the call. The warming we are watching now did not switch on overnight. It built through the spring in signs that satellites could see from orbit, and those early signs are where the story really starts. The first clues did not show up as heat you could feel. They showed up as a change in the height of the sea. Warm water takes up slightly more room than cool water. When a body of water warms, it swells, and its surface rises a little. The rise is small, only inches, but it covers such a wide area that instruments in space can measure it. A satellite called Sentinel-6 Michael Freilich, run jointly by the United States Space Agency and its European partners, does exactly that. It circles the Earth and reads the height of the sea surface with great care. In the spring of this year, that satellite began to see the ocean surface rising across parts of the tropical Pacific. Higher sea surface meant warmer water underneath. The map the scientists drew showed a band of higher water reaching across the central and eastern Pacific towards South America. That band is the visible shape of El Niño taking hold. Behind that rise was a slower, hidden event. Deep under the surface, large pulses of warm water had begun moving east. Scientists call these pulses Kelvin waves. They are not waves you would ever see at a beach. They are broad, gentle swells of warm water, hundreds of miles wide, travelling slowly along the equator below the surface. When the trade winds weaken, these warm pulses are set loose and roll eastward, like warmth moving along under a blanket. As each warm pulse reaches the eastern Pacific, it rises toward the surface and adds its heat to the top of the ocean. That is much of what fed the warming through the spring. One pulse after another carried warm water east and lifted the surface temperature step by step. A scientist at the Space Agency's Jet Propulsion Laboratory compared what she saw in early June with the same time of year in 1997. That year is famous among ocean watchers because it produced one of the strongest El Niño events ever recorded. In the Western Pacific, this year looked a great deal like that one. There was one difference worth noting, honestly. The Eastern Pacific was lagging behind. Fewer of those warm pulses had reached the far eastern side by early June than had arrived by the same point in 1997. So the event looked powerful, but it had not yet fully caught up to that famous year. More warm pulses appeared to be on the way, which meant the warming was likely to keep building. Whether it would match 1997 was still an open question, and the scientist said as much. Her read was that it looked like a big one, more so than she would have guessed only a week earlier, but that more measurements were needed to be sure. These space measurements matter because they let forecasters see the event coming before it fully arrives. The rising sea and the moving warm pulses are early news from the ocean. They gave the agencies weeks of warning that the warm phase was forming. While the deep ocean was loading up with warm water along the equator, something else was happening closer to home, off the west coast of North America, and it is worth understanding on its own. Off the western edge of North America, the ocean had turned unusually warm through the spring. This was a separate event from the one building along the equator, and keeping the two apart helps the whole picture make sense. A long stretch of warm surface water sitting in one place is called a marine heat wave. It is the ocean's version of a hot spell on land. The water near the surface heats up and stays hot for weeks or months, instead of mixing back to its usual temperature. This spring, a marine heat wave spread across a wide part of the northeastern Pacific, the waters reaching from California up toward the Pacific Northwest. The cause was not El Niño, at least not at first. The warm coastal water was driven mostly by a pattern in the air and sea off North America that scientists track on its own. In that pattern, the winds that normally stir and cool the surface ease off, and the water warms in response. It is a regional event with its own rhythm, separate from the warm tongue down at the equator. Here is why it still belongs in this story. That coastal pattern often shows up in the spring just before an El Niño begins. The two are not the same thing, but they tend to travel together. When the coastal water warms in this particular way in spring, an El Niño has a habit of following, so the marine heat wave was not the cause of the equatorial warming, it was more like a companion sign pointing the same direction. For people living along the west coast, the nearer effect is simpler to picture. Warm water just offshore makes the air above it warmer and damper. That warmth and moisture can drift inland through gaps in the coastal hills. The result is not always a string of scorching afternoons. More often it is a lifting of the baseline, with warmer nights, muggier air, and fewer of the cool breaks the coast usually gets from the ocean. There is a useful lesson in holding these two warm areas side by side. The Earth's oceans are not a single switch. Different parts can warm for different reasons at the same time. The coastal heat wave came from one regional pattern. The equatorial warming came from the weakening trade winds and the slow march of warm water along the equator. They overlapped this spring, and together they tilted the whole region warm. When several warm signals stack up at once, forecasters pay closer attention. One warm patch could be noise. A warm equator, rising seas, marching warm pulses, and a warm coastline all at the same time tell a more consistent story. They were all pointing toward the same outcome, which is part of why confidence in the forecast grew through the spring. Still, signs are not proof. To turn these scattered clues into a clear call, forecasters lean on a single, well-defined measurement. That measurement is how they decide on the record whether an El Niño is truly underway, and it is worth understanding plainly. To say El Niño is here, and to say how strong it is, forecasters need one steady yardstick. They have agreed on one, and almost everything you hear about the strength of an event traces back to it. The yardstick is the temperature of one particular box of ocean. It sits along the equator in the central Pacific, a wide rectangle of open water far from any coast. Scientists call this box the Niño 3.4 region. They measure the temperature of the surface water inside that box, then compare it with the long-term average for the same time of year. The difference between the two is the number that matters. If the water in that box is warmer than its average by about 1 degree Fahrenheit or more, and stays that way, the warm phase is underway. The threshold the scientists use is a little under 1 degree Fahrenheit above normal, held for several months in a row. Cross it and stay there, and the ocean has earned the name El Niño. Fall the same distance below average, and it would be the cool phase instead. The strength of the event is just a matter of how far past that line the water climbs. A small step over the line is a weak event. Warmer than about 2 degrees Fahrenheit above normal is a moderate one. Past roughly 3 degrees Fahrenheit above normal, the event is called strong, and when the water runs more than about 3.5 degrees Fahrenheit above its average, forecasters use the term very strong, the level some people call a super El Niño. By the middle of June, that box of ocean was running near 3 degrees Fahrenheit above normal in the weekly readings. That already placed it in strong territory for the moment, with room to climb. The official seasonal figure, which averages over 3 months and smooths out the weekly jumps, was still catching up and sat lower. That gap is normal. The weekly number reacts fast. The seasonal average moves slowly, because it waits for the warming to hold before it fully counts it. There is a newer measurement that forecasters have leaned on more in recent years. The older yardstick compares the box with its own past. The newer one compares the box with the rest of the tropical oceans, which have all been warming over time. By measuring the Pacific against that wider warmth, the newer method does a better job of telling forecasters how the atmosphere is likely to respond. It keeps the focus on the difference that actually drives weather, rather than on warming that is happening everywhere at once. This distinction will matter later in the story. When the whole planet is warm, a simple comparison with the past can make an event look enormous, partly because the baseline has shifted. The newer method tries to separate the El Niño signal from the broad background warmth. Both numbers are useful. Together they keep the picture honest. For now, the plain reading is this. The water in the box has crossed the line, it has crossed it by a wide margin, and the official seasonal count is rising to meet the weekly readings. The event is real, and it is not weak. What surprised many of the people who watched these numbers was not only how high the water climbed, it was how quickly it got there. Speed is part of what makes this event stand out. The warming did not creep up over a long, slow season. It came on fast. Earlier in the year, the Central Pacific was close to normal, sitting near the middle of the range, neither warm nor cool. Within a few months, the same stretch of ocean had climbed well past the line that marks El Niño and kept going. That is a quick rise for this part of the Pacific. Forecasters described it as one of the sharper spring warm-ups they had seen in recent years. A fast warm-up matters for a practical reason. It gives the event more room and more time to grow before it reaches its natural peak. El Niño tends to top out in late autumn or winter. An event that is already strong by early summer has months of warm season ahead in which to build further. A slow starter might never reach its full size before the calendar turns it back. A fast starter has the runway to become something large. The cause of the quick rise goes back to the warm pulses moving along the equator. Through the spring, one warm pulse followed another in fairly close order. Each one delivered a fresh load of warm water to the eastern Pacific and lifted the surface temperature again. When these pulses arrive in a steady train, with little gap between them, the warming stacks up quickly. That appears to be what happened this spring. The ocean kept getting reloaded before it had a chance to cool. It helps to compare two ways an event can build. In a slow year, the warm pulses arrive far apart, and the ocean partly recovers between them, so the warming climbs in small, uneven steps. In a fast year, the pulses come close together, and each one builds on the last before the surface can settle. This spring looked like the fast kind. The pushes came in close succession. There is a second reason the rise drew attention. It happened from a starting point that was already warm. The Pacific was not climbing out of a cold phase, where there would be a deep store of cool water to overcome first. It was rising from near the middle, with less cool water in the way. With less to push against, the warming met less resistance and climbed more freely. A quick rise also raises the stakes for the forecast. When an event builds fast and early, it tends to draw the attention of every major forecasting centre at once. More models begin to agree, and they begin to agree on a larger outcome. That is part of what happened here. As the spring warming accelerated, the forecasts for the coming autumn shifted upward, toward a stronger peak than many had expected at the start of the year. Speed alone does not guarantee a record. A fast start can still level off. But it does change the odds. It moves a weak or moderate event off the table and puts a strong or very strong one squarely in view. That is why forecasters took the early pace seriously rather than waiting to see if it would fade. The ocean had done its part by warming quickly. For this to become a full event, with worldwide reach, the air above the ocean had to respond as well. That response is the next piece, and it is the part that turns a warm ocean into a global event. A warm ocean is only half of an El Niño. The other half is in the air, and without it the event never truly takes hold. In a normal year, the trade winds blow from east to west across the tropical Pacific, and the air rises over the warm western side near Indonesia. Rising air there means clouds and heavy rain over the western Pacific. Far to the east, over the cooler waters near South America, the air sinks and the weather stays drier. This loop of rising air in the west and sinking air in the east, joined by winds high above and at the surface, is a great turning wheel of the atmosphere. Scientists named it after the man who first described its surface signs and call it the Walker circulation. El Niño tips this wheel. As the warm water spreads into the central and eastern Pacific, the place where the air rises most strongly slides east with it. Now the heavy rain and rising air sit over the central Pacific instead of over Indonesia. The sinking, drying air moves over the western Pacific, over Indonesia and Australia. The whole wheel shifts position. The winds weaken or reverse, the rain relocates, and the drought and the downpour trade places. This shift in the wheel is what carries El Niño to the rest of the world. The rising air over the central Pacific does not stop at the top of the sky. It spills outward and changes the path of the fast, high rivers of air that steer storms across the middle latitudes. When those high winds move, the storm tracks move with them. A change in where the tropical air rises becomes a change in winter weather over North America, in rainfall over Africa, in the storms that reach South America. This is also why the ocean and the air must agree before forecasters call an event real. The water can warm for a stretch without the wheel responding. If the trade winds keep blowing as usual and the rain stays put, the warm water alone does little to the wider world. Only when the winds slacken, the rain shifts east, and the great wheel leans over does the warming earn the name and start to reach far places. This time, the air responded. The winds eased, the rising air began to move east, and the atmosphere joined the ocean. There is a useful way to picture the coupling. Think of the ocean and the air as two dancers who have to move together. If only one moves, nothing carries. When both lean the same way at the same time, the motion feeds on itself. The warm water makes the air rise. The rising air weakens the winds. The weaker winds let more warm water spread, and the warm water makes the air rise more. Each step strengthens the next. That feedback is how a modest warm patch can grow into a powerful event, and it is part of why a fast start can run so far. Watching the air is how forecasters separate a true El Niño from a near miss. Some years the ocean warms a little, but the atmosphere never commits, and the event stays weak and quiet. The strength of this year's atmospheric response was one of the clearest signs that the event was genuine and likely to grow. So the ocean had warmed quickly, and the air had leaned in to match it. By itself, that would make a notable El Niño. What makes this one stand apart from every El Niño before it lies not in the Pacific at all, but in the state of the whole planet it is arriving on? Here is the part that has no clear precedent in the records we have. A strong El Niño is not new. The world it is forming on is. The planet today is warmer than at any point in the long record kept with instruments. The world has warmed by close to 2.5 degrees Fahrenheit since the late 1800s, most of it in recent decades. Every El Niño in the modern record formed on a cooler planet than the one we have now. The strong events of the past arrived on a world that had not yet warmed this far. This one is arriving on the warmest background ever measured. A climate scientist put the point plainly this spring. In modern human history, he said, we have never seen a strong or very strong El Niño form on top of conditions already this warm across the whole globe. That single sentence is the truest version of what makes this event unusual. It is not that the warm phase returned, it is the floor it is standing on. Why does the background matter so much? El Niño adds a burst of warmth to the world for a year or so. It releases heat that the Pacific has stored, and that heat spreads into the air and lifts the global average for a time. In the past, that burst was added to a cooler starting point. Now the same burst is added to a planet that is already running hot. The two warmings stack. The El Niño heat sits on top of the long, steady warming that human activity has been adding for over a century. There is a plain way to see the difference. Think of a tide rising onto a beach. The long warming from greenhouse gases is like a slowly rising sea level, lifting the whole baseline year after year. El Niño is like a high tide that comes in for a season and then goes back out. A high tide on a low sea reaches a certain point. The same high tide on a sea that has already risen reaches higher ground and floods places the old tide never touched. The tide has not grown larger. The water it climbs from has. This stacking is why scientists are watching the coming year with such care. The added warmth from a strong El Niño, laid over today's heat, raises the odds of new records. Forecasters say there is a real chance that this year or next, or both, could set a new mark for the warmest year the world has measured. That would not be a surprise. It would be the expected result of a warm event on an already warm world. It also changes what the familiar effects might do. The droughts El Niño usually brings could bite harder when they start from soil that is already dry and hot. The heat waves could run hotter when they build on a warmer baseline. The fire seasons could be longer where the land is drier than it used to be. None of this is certain, and the rest of this report will keep the claims tied to the evidence. But the reasoning is sound, and it follows from simple arithmetic. Add a warm event to a warm world, and you get more warmth than either would give alone. This is the heart of why the event is worth a careful look. The mechanism is old and well understood. The setting is new. To weigh how far this one might go, it helps to look at the handful of times the Pacific has warmed this much before, and at what those events did. Very strong El Niño events are rare. In the years since reliable records began, only 3 stand out clearly at the top. Knowing them helps put this year in scale. The first came in the winter of 1982 into 1983. The second arrived in 1997 into 1998, and it is often used as the benchmark for a powerful event. The third was the winter of 2015 into 2016. Each of these pushed the Central Pacific to more than about 3.5 degrees Fahrenheit above its normal temperature, the level forecasters call very strong. Each left a deep mark on the world's weather for a year or more. These three events share a family resemblance. They brought drought to Indonesia, Australia, and parts of southern Africa. They brought heavy rain and flooding to coastal Peru and Ecuador. They warmed the global average and helped push the years that followed to record heat. The winter of 1997 into 1998, in particular, is remembered for floods in the Americas, fierce fire seasons in the Western Pacific, and a worldwide spike in temperature. It helps to put plain numbers on the words. A weak El Niño nudges the Central Pacific only a little above its average. A moderate one warms it to around 2 degrees Fahrenheit above normal. A strong one reaches about 3 degrees above normal. A very strong one passes 3.5 degrees and keeps climbing. The three famous events all reach that top tier. Most El Niño years never do. They stay weak or moderate and pass with far less notice. Part of what makes the very strong event so consequential is that the warmth lingers. A super event does not warm the Pacific for a few weeks. It holds the ocean warm through an entire autumn and winter, sometimes longer. That long stretch of warmth gives the atmosphere time to settle into a new pattern. Storm tracks shift and stay shifted for months. Dry regions stay dry through a whole season. The effects are not a single storm or a single hot week. They are a season-long change in the rules. There is a sobering footnote to the recent very strong events. Each one fell during the long warming of the past several decades, and each helped set or approach a record for global heat in its year. The warmest years on record have a habit of landing in, or just after a strong El Niño. That pattern is part of why forecasters take a developing very strong event so seriously. It tends to leave a record behind it. The honest caution is that 3 events are a small sample. With only a handful of very strong El Niño years to study, scientists are careful about drawing firm rules from them. They can describe what those years did. They are more cautious about promising that the next one will follow the same script, especially on a planet that has changed since the last one. The records with instruments reach back only so far. To find a warming that may have rivaled what some models now suggest for this year, you have to look further back still, to a time before anyone alive today was born, and to an event remembered for the harm it caused. In the 1870s, the world endured what many scientists believe was one of the most powerful El Niño events in centuries. It came before modern weather instruments, so its size is reconstructed from records of rain, harvests, and ship logs rather than measured directly. But its effects were vast and they were tragic. That event spread drought across India, China, Brazil, and parts of Africa at the same time. Crops failed across whole regions. The drought, made worse by the policies and conditions of the time, helped bring on famines that killed an enormous number of people. Historians estimate the death toll across the affected countries ran into the tens of millions, with figures often cited near 50 million. It stands as one of the deadliest weather-driven disasters in recorded history. The reason to recall it now is not to frighten anyone. It is to mark the upper edge of what the Pacific can do, and to be honest that some models this year have pointed toward that extreme range. A few forecast runs have suggested the Central Pacific could climb toward about 5.5 degrees Fahrenheit, above normal at the peak. A warming that large has been reached only once in the data scientists trust, around the start of 1878. That is the link to the historic event. The model is not predicting a famine. It is pointing toward a level of ocean warming last approached in that distant year. It is important to be careful with this comparison, and the scientists who raise it are careful too. The high-end model runs are possibilities, not promises. They sit at the warm edge of a spread of forecasts, and the spread is wide. The most likely outcome is a strong or very strong event, which is serious enough. The chance of matching the 1870s in raw ocean warmth is real, but far from certain, and no one can say at this stage whether it will happen. The other half of the comparison is more hopeful, and it deserves equal weight. The world of the 1870s had no satellites, no seasonal forecasts, and no warning. People had no idea the drought was coming or why. Today the warning arrives months ahead. Governments and aid agencies can see the risk forming and act before the worst of it. Stores of food can be moved, water can be saved, farmers can plant hardier crops. The hazard from the ocean may be comparable in size, but the ability to prepare for it is not. That difference can save a great many lives. So the 1870s serve two purposes in this story. They show how far this pattern can reach when it runs to its extreme, and they remind us how much has changed in our power to see it coming and soften the blow. The same ocean that brought catastrophe then is being watched now, day by day, by satellites and forecasters who can give the world time to get ready. With the past in view, the question turns back to the present. The ocean is warm and still warming. The pressing matter is what the forecasters now expect it to do through the rest of this year. Looking ahead to the autumn, the forecast leans clearly toward a stronger event, not a fading one. The major forecasting centres have moved into rough agreement on that point. The United States agency that issued the advisory expects the event to intensify to at least a moderate or strong level by the fall. It puts the chance of the event reaching the very strong tier, more than about 3.5 degrees Fahrenheit above normal, at a little under 2 in 3. In plain terms, the most likely path is a strong event, with a serious chance of a very strong one. A weak finish now looks unlikely. Other centres around the world agree on the direction. A consensus of models from forecasting groups across several countries points to a developing and strengthening event through the autumn, with the peak expected late in the year. Many of those models place the high point in the autumn months and show the warming holding into the winter. The odds that the warm phase continues through the Northern Hemisphere winter run very high, near or above 9 in 10 by most counts. A few of the models go further and push toward the extreme range, the level discussed a moment ago. Those high-end runs are real, and they are part of why scientists are paying such close attention. But they sit at the warm edge of the forecast, not the centre. The careful reading keeps them in view without treating them as the expected result. The centre of the forecast is a strong to very strong event peaking next winter, which is consequential on its own. It helps to understand why forecasters trust a longer-range outlook for this pattern more than they trust most long-range weather forecasts. El Niño moves slowly, and it carries a great deal of stored heat that does not vanish overnight. Once a large warm pool is in place, and the atmosphere has locked onto it, the event tends to hold its course for months. That slow, heavy quality is what lets scientists see its arrival and its peak from seasons away. It is far easier to forecast the broad path of El Niño months ahead than to forecast next week's rain in any one town. The timing in the forecast follows the natural rhythm of these events. El Niño usually begins to build in spring or early summer, grows through the autumn, and reaches its strongest point in late autumn or winter. Its largest effects on weather around the world tend to land in that winter window and in the months that follow. So the calendar ahead points toward a peak late this year, with the widest reach of its effects spread across the winter and into the next year. The agencies update these outlooks once a month. Each update folds in the newest ocean readings and the latest model runs, and the numbers shift a little each time as the picture sharpens. The broad message has held steady for weeks. The event is growing, the peak is months away, and the most likely outcome is a powerful one. A forecast, even a confident one, is still a forecast. The honest next step is to be clear about what could still go differently, and about the limits of what anyone can know at this stage. For all the agreement among the models, real uncertainty remains, and saying so plainly is part of an honest report. The first uncertainty is whether the event will keep climbing or level off. El Niño does not always grow in a straight line. A developing event can stall for a stretch if the supply of warm pulses along the equator slows, or if the winds briefly pick back up and check the warming. The fast spring rise raised the odds of a large peak, but it did not lock one in. The ocean could pause, and a pause at the wrong time could leave the event strong rather than very strong. A specific sign was worth watching this spring. The Western Pacific looked much like the famous event of 1997, but the Eastern Pacific lagged behind, with fewer warm pulses arrived than by the same date that year. Whether this event catches up to that benchmark depends on how many more warm pulses reach the eastern side in the coming weeks. The scientist who made the comparison was careful to say it would take more measurements to know. Her honest read was that it looked like a big one, more than she would have guessed a week earlier, but that the ocean still had to show its hand. The second uncertainty is harder, and it comes back to the warm world the event is forming on. Because no strong El Niño has ever formed on a planet this warm, the past is a less reliable guide than usual. The maps that show what a typical El Niño does to rain and temperature are built from past events on a cooler Earth. They are still useful, but they may not capture how the warmer background changes the outcome. The event may follow the old patterns closely. It may also bend them in ways the records cannot show us in advance. There is a deeper version of this caution that one scientist raised directly. With only a few very strong events to learn from, and none on a world like today's, anyone who claims to know exactly how this will unfold, or how long its effects will last, is leaning on a thin base. Some have suggested a strong event now could lock in warming for years to come. Others say it may simply give a one-year boost and then fade. The honest position is that the small sample does not support strong confidence either way. Scientists can lay out the possibilities. They cannot yet rank them with certainty. It is worth separating two things that often get blurred. The forecast for the ocean itself, the warming in that central Pacific box, is relatively confident. The models agree that it will be strong and probably more. The forecast for exactly what that warming will do to any one region, in any one month, is far less certain. The ocean signal is clear. The translation of that signal into local weather carries much wider error. This is also where breathless coverage can run ahead of the science. Some headlines this spring have already declared a record-breaking disaster as a settled fact. The measured truth is narrower. A powerful event is likely. A record warm year is plausible. The extreme high-end outcomes are possible but far from assured. Holding those distinctions is how the picture stays honest. So the ocean has set a strong event in motion, and the forecasters expect it to grow, while keeping clear about what they cannot yet promise. The next stretch of this report turns from the Pacific itself to the wider world, beginning with the simplest effect of all, the warmth this event is likely to add to the whole planet. The simplest worldwide effect of El Niño is also the easiest to overlook. It makes the whole planet a little warmer for a year or so. The reason is the heat itself. The Pacific Ocean holds a vast amount of warmth below its surface. During the cool phase of the cycle, much of that heat stays buried under the water. During El Niño, the warm water rises and spreads across the surface, where it can pass its heat into the air. Heat that was hidden in the ocean comes out into the atmosphere. Spread that release across thousands of miles of tropical ocean, and it lifts the average temperature of the entire globe for a time. The lift is not enormous, but it is real and measurable. A strong El Niño can add a few tenths of a degree to the global average for the year that follows it. That sounds small until you remember it is an average across the whole Earth, land and sea, day and night, pole to pole. A few tenths of a degree in that figure is a large amount of extra heat in the system. This is why the warmest years in the record tend to cluster around strong El Niño events. The cool phase tucks heat away and holds the global average down. The warm phase pulls heat out and pushes the average up. Lay that natural up and down on top of the long climb from greenhouse gases, and the strong El Niño years tend to land at new highs. The pattern has repeated through the recent very strong events. Each helped its year reach near the top of the record. That history is why forecasters say there is a real chance this year, or next, or both, could set a new mark for the warmest year ever measured. The reasoning is the stacking described earlier. The event adds its burst of warmth to a planet already at its hottest. The sum is likely to be higher than either part alone. A new record would not be a shock. It would be the ordinary result of a warm event on a warm world. The timing of the lift matters as much as its size. El Niño's boost to global temperature does not peak at the same moment the ocean peaks. It tends to lag. The ocean usually reaches its warmest in late autumn or winter, but the strongest push to the global average often comes in the months after that, well into the following year. So even though the Pacific may top out next winter, the warmest stretch for the planet as a whole could come later still, in the year beyond. It helps to picture the ocean as a giant storage heater. Through the cool years, it soaks up heat from the sun and stores it in the deep water. During El Niño, it gives some of that stored heat back to the air. The planet does not gain new heat from El Niño. It simply moves heat from the ocean into the atmosphere, where thermometers can feel it. The cycle shifts warmth around rather than creating it. But to the air, and to us, the shift is what we measure. For most people, this planet-wide lift will not be the part they notice. They will notice the local effects, the dry spell or the heavy rain, the hot month or the mild winter. Those local changes are where El Niño touches daily life, and they vary sharply from one part of the world to another. The global average is the quiet backdrop behind all of them. There is one steadying point to hold here. The extra warmth from El Niño is temporary. When the event fades and the cool phase eventually returns, the ocean will begin storing heat again, and the global average will ease back down from its El Niño peak. The long climb from greenhouse gases continues underneath, but the El Niño bump itself comes and goes. This is a spike on a rising line, not a permanent step. Understanding that keeps the event in proportion. It is large, it is real, and it will pass. That worldwide warmth is the broad backdrop. The sharper effects, the ones that change a season for a whole country, come from where the rain moves. The first place to feel that shift is the western edge of the Pacific, where the warm water is leaving and the rain is following it east. When the warm water slides east, the western Pacific is left drier, and that is where Australia and its neighbours come in. For them, El Niño most often means drought. Recall the normal pattern. In an ordinary year, the warm water and the rising raining air sit over the western Pacific near Indonesia and northern Australia. That is what keeps the region wet. During El Niño, the warm water and the rain shift east into the central Pacific. The rising air that used to feed storms over Australia now feeds them over open ocean far away. The air left behind over Australia tends to sink, and sinking air brings clear skies and dry weather. For much of Australia, especially the east and north, that shift tilts the odds toward a drier, hotter stretch than usual. Winter and spring rains can fall short. Reservoirs draw down, the land dries out. By the time the hottest part of the year arrives, the soil and the vegetation are parched and ready to burn. El Niño years in Australia have a long history of drought, water restrictions and dangerous fire seasons. This year the concern is sharpened by the warm background. A dry season that begins from already warm, dry conditions can run harder than the same season would have on a cooler Earth. The reasoning is the same stacking seen before. The El Niño dryness lands on top of a long-term drying and warming, and the two add together. Scientists have flagged elevated fire risk for Australia later this year, and into the next as a result. The effect reaches beyond Australia to the broader region sometimes called the Maritime Continent, the great scatter of islands that includes Indonesia, Malaysia and Papua New Guinea. These islands sit right where the rain normally pools. When El Niño pulls the rain east, they can swing from their usual wet abundance toward drought. That swing matters enormously because so much of the region's farming, water and forest depends on reliable rain. There is an honest complication worth naming. El Niño is not the only pattern in play. Another, in the Indian Ocean, can either add to El Niño's drying over this region or push against it. This year, forecasters have been watching the Indian Ocean pattern closely, because it looked likely to swing into a phase that would reinforce the drought across the eastern Indian Ocean and the western Pacific. When the two patterns line up, the dry signal grows stronger. When they oppose, the outcome is muddier. The careful read keeps both in view, rather than blaming El Niño alone. For the people of the region, the practical guidance is the standard kind, and it is calm and familiar. Watch the official seasonal outlooks from the National Weather Services. Where drought is forecast, save water early rather than late. Farmers can favour hardier, shorter season crops that need less rain. Communities in fire-prone areas can clear the ground around homes and have a plan to leave earlier for fire warning comes. None of this is dramatic. It is the ordinary, steady preparation that turns a hard season into a survivable one. The scale of what is at stake here is large. This is one of the most densely settled and heavily farmed parts of the world. A failed wet season touches food supplies, drinking water, and livelihoods for many millions of people. That is why the forecasts matter so much, and why the months of warning that satellites and models provide are so valuable. The region has time to prepare that it would not have had a century ago. The dryness does not stop at the islands of the Western Pacific. It carries across Southeast Asia, where the same shift in the rain brings its own particular hazard, one that fills the sky with smoke. Across Indonesia, the Philippines, and the rest of Southeast Asia, El Niño most often means a long, dry, fire-prone season. This year the risk has drawn early attention. The mechanism is the one already described. With the rain pulled east into the central Pacific, the islands and peninsulas of Southeast Asia tend to dry out. The monsoon rains can arrive late or fall short. Rivers drop. The thick tropical vegetation, normally too damp to burn easily, dries enough to catch and carry fire. In a strong El Niño, that drying can be severe. The particular hazard here is not only the fire but the smoke. Much of the land in parts of Indonesia and its neighbours is peat, a deep layer of partly decayed plant matter that holds a great deal of carbon. When peat dries out and catches fire, it does not burn like a grass fire and go out. It smoulders underground for weeks or months, pushing out thick smoke the whole time. In past strong El Niño years, peat fires have blanketed wide regions in haze, closing schools and airports and sending people to hospitals with breathing trouble. The smoke can drift across borders, turning a fire in one country into a health emergency in several. The Philippines faces a related but distinct problem. As a chain of islands in the Western Pacific, it sits squarely in the zone that dries during El Niño. The concern there is often water and farming. Reduced rain can lower the reservoirs that supply cities and the water that irrigates rice. In strong events, the country has faced water rationing and crop losses. Heat is a worry too, since the dry, sunny weather that comes with El Niño can drive temperatures up. This year, the fire risk has already shown itself early. Scientists tracking the global fire season reported that it had started fast, with notable activity in Southeast Asia among other regions. A fast start, combined with a forecast strong El Niño, points toward a difficult season ahead. One researcher described the likelihood of harmful, extreme fires as potentially the highest seen in recent years, given how early the burning had begun. It is worth being precise about the cause. El Niño does not light the fires, people and lightning do. What El Niño does is dry the land and lengthen the dry season, which makes fires far easier to start and far harder to stop. Much of the burning in this region traces to land being cleared, often for agriculture. In a wet year, those fires stay small and contained. In an El Niño drought, the same spark can run out of control. The pattern sets the stage. It does not strike the match. The guidance for people in the region follows the hazard and stays calm and standard. Pay attention to local air quality warnings and stay indoors with windows closed when the smoke is heavy. A well-fitting mask helps filter the worst of the smoke particles for those who must go out. Keep an eye on official fire and drought bulletins and follow any guidance on water use early in the season. For those near forest or peatland, clearing dry material from around buildings and knowing the local warning system are sensible steps. The reach of this drying is wide, but it has an inland counterpart as well. Carrying west across the ocean, the same shifted pattern brushes the vast population of India, where the question turns to the most important rains of the year. For India, the central question every year is the monsoon, and El Niño has a long and worrying relationship with it. The monsoon is the heavy rain that sweeps across the country through the summer, and the entire year depends on it. The monsoon is the lifeblood of Indian farming. Most of the country's rain falls in those few summer months, and most of its crops depend on that rain arriving on time and in full. A good monsoon means full reservoirs, healthy harvests and steady food supplies. A weak monsoon means dry fields, low water, and pressure on food and prices for hundreds of millions of people. Few weather questions on Earth carry higher stakes for so many. El Niño tends to tilt the monsoon toward weakness. The connection is not perfect, and not every El Niño year brings a poor monsoon, but the link is strong enough that India's forecasters watch the Pacific closely each spring. When the warm phase takes hold, the rising air shifts away from the region, and the flow of moisture that drives the monsoon can falter. Many of India's driest monsoon years in the historical record have fallen during El Niño events. The reason ties back to the Great Wind Wheel over the Pacific. When El Niño moves the rising air east into the central Pacific, it can disturb the circulation that pulls moist air over India in summer. The monsoon does not switch off, but it can weaken, with longer dry breaks between the rains and lower totals overall. In a strong event, the risk of a below-normal monsoon rises. This year, forecasters have flagged India among the regions facing drought risk as the event develops. The concern is the familiar one. A weak monsoon would lower reservoirs, strain irrigation, and put pressure on the harvest. On top of a warm year, the heat that often accompanies a dry monsoon could push temperatures to dangerous levels in the pre-monsoon and post-monsoon stretches when the cooling rains are thin. The honest qualifier matters here too. The monsoon answers to more than El Niño alone. That same Indian Ocean pattern mentioned earlier can either deepen the drying or counter it. In some past years, a favourable Indian Ocean phase has cushioned the blow of an El Niño and kept the monsoon closer to normal. So while the risk of a weak monsoon is real and worth preparing for, it is not a certainty. The outcome will depend on how these patterns combine through the summer. The scale of what depends on this rain is hard to overstate. A large share of the world's people live in the lands the monsoon waters, and a large share of them farm. A poor monsoon does not just mean a dry season. It can mean higher food prices, water shortages in cities, and hardship that ripples through the economy. This is one of the clearest examples of how a warm patch of ocean far out in the Pacific can reach into daily life on the other side of the world. The preparation here is national in scale, and much of it is already underway. India's agencies issue monsoon forecasts and update them through the season. Governments can manage water in the reservoirs carefully, hold reserves of grain against a poor harvest, and advise farmers on which crops to plant. The early warning from the El Niño forecast gives those agencies months to plan, which is exactly the advantage the world of the 1870s lacked. From the Indian Ocean, the pattern's reach extends to the African continent, where El Niño splits the map, drying one part while signalling change in another. Africa shows El Niño's split personality clearly. The same event that dries the south can tilt the east the other way, and the continent ends up divided. Start with southern Africa, where the effect is most consistent. Countries such as South Africa, Zimbabwe, Zambia, and their neighbours depend on a summer rainy season that runs roughly from late in the year into the early months of the next. El Niño tends to suppress that rain. The pattern shifts the moisture away, and the region leans toward drought. Many of southern Africa's worst droughts have fallen in El Niño years, including severe ones in the recent past that left millions short of food and water. The stakes in southern Africa are high because so much of the farming there depends directly on rain rather than irrigation. When the rains fail, the maize crop, a staple food across the region, can fail with them. The result is not an abstract statistic. It is empty fields, thin harvests, and families struggling to find enough to eat. Aid agencies have learned to watch the El Niño forecast as an early signal to prepare food assistance for the region. This year, scientists and aid groups have again flagged southern Africa among the areas facing drought risk as the event builds. The familiar caution applies. A drought that begins from already warm, dry conditions can run harder. The warning is going out early, which gives governments and aid organisations time to position food and plan support before the worst arrives. The eastern part of the continent often tells a different story. The Greater Horn of Africa, the region including parts of Ethiopia, Somalia, and Kenya, can respond to El Niño in a more complicated way, with some seasons turning wetter rather than drier. In some past El Niño years, Eastern Africa has seen heavy rain and flooding instead of drought. The relationship there is less reliable than in the south, and it depends heavily on that Indian Ocean pattern, which has a strong grip on East African rains. This year the eastern signal has been mixed, and forecasters have been careful with it. Early outlooks pointed toward a high chance of below normal rainfall across much of the northern Greater Horn during one of its key rainy seasons, which would lean the region toward dryness rather than the flooding El Niño sometimes brings. The outcome there will hinge on how the Pacific and Indian Ocean patterns combine, and the careful read holds the uncertainty openly rather than forcing the region into the simple El Niño script. The lesson of Africa is a useful corrective to a common mistake. It is tempting to think El Niño does one thing everywhere. It does not. It moves the rain, and whether that means more or less for any given place depends on where that place sits relative to the shifted pattern. The south dries with fair reliability. The east is genuinely uncertain. Naming a region as at risk only where the evidence supports it is the honest approach, and Africa is where that discipline matters most. The guidance across the continent matches the hazard. Where drought is forecast, the steps are the standard ones: saving water, managing reserves, supporting farmers with hardier crops, and moving food aid early. Where flooding is possible, the steps are different: clearing drainage, avoiding building in flood paths, and heeding evacuation warnings. The right preparation depends on the local forecast, which is exactly why the regional outlooks matter so much. Crossing the Atlantic, the pattern reaches the Americas, where El Niño writes one of its most reliable stories on the western coast of South America, and a slower one in the Great Forest at the continent's heart. South America holds two of El Niño's most distinct signatures, one fast and one slow. The fast one falls on the Pacific coast. The slow one builds in the Amazon over the following year. Begin on the coast of Peru and Ecuador, where the El Niño story actually began centuries ago. The name itself comes from this coast. Local fishermen long ago noticed that the ocean warmed near the end of the year, around Christmas, and they named the warming after the Christ child. That coastal warming is El Niño at its source, where the warm water reaches the eastern edge of the Pacific and presses against the land. For Peru and Ecuador, a strong El Niño most often means heavy rain and flooding. The warm water just offshore feeds storms that drench the normally dry coast. Rivers swell, hillsides give way, and floods can wash through towns that see little rain in an ordinary year. The strong events of the past have brought serious flooding to this coast, with damage to homes, roads, and farmland. This is one of El Niño's most dependable effects, written on the same coastline that gave the pattern its name. The guidance on this coast centres on water and on slopes. Communities can clear drainage before the rains, avoid building in the paths where floodwater runs, and heed warnings to move to higher ground when heavy rain is forecast. Landslides are a particular danger where rain falls on steep, bare hillsides, so knowing the local risk and the evacuation routes matters. The forecast gives months of warning, which is time enough to prepare if it is used. Then there is the Amazon, where El Niño works more slowly and more quietly, but with great consequence. The vast rainforest depends on a steady cycle of wet and dry seasons. El Niño tends to reduce the rainfall over much of the Amazon, drying the forest beyond its normal dry season state. A drier forest is a more flammable forest. The important point about the Amazon is the lag. The most severe fire risk usually does not arrive in the same year the El Niño peaks. It comes the year after. The reasoning is that a reduced wet season leaves less water stored in the forest, so the following dry season starts from a drier base and runs harder. Scientists this year have pointed specifically to the second half of the next year as the most likely window for potentially record-breaking fire activity in the Amazon, once the reduced rains of this El Niño have had time to dry the forest out. This lag is a recurring theme worth holding on to. El Niño does not deliver all its effects at once. Some land quickly, like the coastal floods. Others build over many months, like the Amazon drought and fire risk. The event peaks in the ocean over a single winter, but its consequences are spread across 2 years. The forest fires of the second year are among the slowest and most serious of those delayed effects. The Amazon matters far beyond its borders. It is one of the world's great stores of carbon and one of its richest reserves of life. A severe fire year there is not only a regional tragedy, it releases carbon that adds to the long-term warming, and it damages a forest the whole planet relies on. That is why scientists watch the Amazon's response to El Niño so closely, and why the warning for the next year is being raised now. From South America, the pattern's reach extends north, into the part of the world where El Niño's winter signature is best known and most studied, across the United States and Canada. Across North America, El Niño's clearest mark falls in winter, and it comes from a shift in the high, fast winds that steer the continent's storms. The key player is the jet stream, a river of fast-moving air high in the sky that guides weather systems from west to east. In a normal winter, it follows one set of paths across the continent. During El Niño, the warmth and rising air in the tropical Pacific nudge the jet stream into a different arrangement. Over the North Pacific, it tends to extend and shift southward, and that shift changes which parts of the continent get the storms. The most reliable result is a wetter pattern across the southern tier of the United States. The southward shifted storm track tends to carry more storms across the south, from California and the southwest, across Texas, and toward the southeast. For these regions, an El Niño winter often means more rain than usual, and in the mountains of the west, more snow. After dry years, that extra moisture can be welcome, refilling reservoirs and snowpack. In excess, it can bring flooding. Farther north, the pattern tends to run the other way. The northern United States, the Ohio and Tennessee valleys, and the northern Rockies often turn drier and milder during El Niño. The storms that would have crossed the north get steered south instead. Winters across the northern states and into Canada tend to come out warmer than usual, with less of the bitter cold and heavy snow that other years bring. For heating bills and travel, a mild northern winter can be a relief. For water supply and for the businesses that depend on snow, it can be a problem. It helps to picture the jet stream as a hose that waters the lawn. In a normal winter, the hose sweeps across one band of the country. El Niño grabs the hose and drags its aim southward. The southern band gets soaked. The northern band, no longer in the spray, dries out and warms. The water did not increase. Its aim moved. The honest qualifier is important. and the head of the United States Weather Service stated it plainly this year. Every El Niño is different. Each one carries its own imprint on the weather, and the broad tendencies described here are odds, not guarantees. A given El Niño winter can depart from the textbook pattern, because other forces in the atmosphere also have a say. The southern wetness and the northern mildness are the most likely outcomes, not certainties for any single place. This year carries an added wrinkle on the west coast, from that separate marine heat wave described earlier. The warm water offshore can lift the baseline warmth and humidity along the coast through the warm season, even before the El Niño winter pattern takes over. So parts of the west may feel a warmer, muggier stretch ahead of the winter, layered on top of whatever the jet stream brings later. The guidance for North America is mild and practical. In the southern states, where a wetter winter is likely, the sensible steps are the ordinary flood precautions, clearing drains and knowing the local flood risk. In the northern states, where a milder, drier winter is likely, the main watch is on water supply and snowpack for the seasons that follow. None of it calls for alarm, it calls for the usual seasonal readiness, informed by the outlook. There is one more North American effect, and it runs in the opposite direction from most of the others. Rather than adding storms, El Niño tends to take them away, out over the Atlantic where it quiets the hurricane season. Not all of El Niño's effects add danger, one of them subtracts it. Over the Atlantic Ocean, El Niño tends to suppress the hurricane season, and that is genuinely good news for the coasts that face those storms. The reason lies in the high winds again, but in a different way. Hurricanes need a calm vertical column to grow. They build best when the winds at the surface and the winds high above are blowing at similar speeds and directions, so the storm can stack up tall and organised. When the winds high up blow much faster or in a different direction than the winds below, they shear the top off a developing storm and tear it apart before it can strengthen. Forecasters call that difference wind shear. El Niño increases wind shear over the tropical Atlantic. The shifted circulation that comes with the warm Pacific sends stronger high-level winds across the Atlantic basin, and those winds make it harder for hurricanes to form and grow. So an El Niño year tends to produce fewer Atlantic hurricanes than a neutral or cool year, and the ones that do form often struggle to reach full strength. For the United States Gulf and East Coasts, the Caribbean and Mexico, that tilts the odds toward a quieter, safer season. This year, the United States Agency has forecast a below-normal Atlantic hurricane season, and El Niño is a central reason. The developing warm phase is expected to keep wind shear elevated over the Atlantic through the heart of the season, holding storm numbers down. After several busy and damaging seasons in recent memory, a below-normal forecast is a welcome change for the people who live along those coasts. There is a mirror image to this, fair to mention. While El Niño calms the Atlantic, it can stir up the opposite effect in the central and eastern Pacific. The warm water there gives storms more fuel, and the shear that hurts Atlantic hurricanes is less of an obstacle on the Pacific side. So an El Niño year can bring a busier hurricane season to the central Pacific, even as it quiets the Atlantic. Hawaii, in particular, sometimes faces a higher risk in these years. The energy does not vanish, it shifts basins. The honest caution that applies to every forecast applies here too, and it carries real weight for safety. A below-normal season does not mean no storms, it means fewer, on average, across the whole basin. A single hurricane can still form, still reach the coast, and still do great harm in an otherwise quiet year. Some of the most destructive storms in history have struck during seasons that were quiet overall, so the right response to a below-normal forecast is not to relax preparations. It is to prepare as always, while knowing the odds of a busy season are lower. The practical guidance for coastal residents does not change with the forecast. Have a plan for where to go if an evacuation is ordered. Keep a supply of water, food, and medicine on hand through the season. Know whether your home sits in a flood or storm surge zone. Heed the official warnings when a storm does approach. A quiet season is a good time to keep these habits, not to drop them. This Atlantic quieting is a reminder that El Niño's ledger has two sides. It dries some lands and floods others. It calms one ocean's storms and stirs another's. Holding both sides keeps the picture honest and keeps the tone calm. But across much of the world, one hazard ties many of these threads together this year, and it has already begun. That hazard is fire. Fire is the thread that runs through many of this year's risks, and the season has already started fast. Several of the effects described so far, the drought in Australia, the dryness in Southeast Asia, the parched Amazon to come, all point toward the same danger. The connection between El Niño and fire is the drought it brings. Fire needs dry fuel. Where El Niño shifts the rain away and dries the land, it lays out that fuel across whole regions. It does not start the fires. It prepares the ground so that any spark, from lightning or from people, can spread. In a strong El Niño, that preparation reaches across several continents at once. This year, the warning came early because the burning came early. Scientists tracking global fire reported that the season had gotten off to a very fast start, with notable activity in the African savanna, in Southeast Asia, and in northeastern China, among other places. By the middle of the year, a very large area had already burned worldwide. A fast start before the strong El Niño has even peaked is a sign that the rest of the year could be severe. The places most at risk follow the drought map. Southeast Asia and the peatlands of Indonesia face the smouldering, smoke-filled fires described earlier. Australia faces a dangerous fire season as its dry, hot stretch deepens. Canada, which suffered a record fire season a couple of years ago, faces elevated risk again, since El Niño tends to bring it hotter, drier summers, and thinner snowpack. And the Amazon, as noted, faces its worst risk in the year that follows, once the reduced rains have dried the forest fully. The warm background raises the danger further, and one scientist made the point directly. A strong El Niño laid over today's elevated temperatures could bring widespread or unusually intense fires, even in places that are normally too damp to burn easily. He pointed to the Amazon and to parts of the Pacific region, where peatlands can smoulder for months once they catch. The worry is not only more fire in the usual places, but fire reaching into places that rarely see it. One researcher summed up the concern for this year in plain terms. The fast start to the fire season, combined with the forecast El Niño, pointed toward a particularly severe year taking shape. The chance of harmful, extreme fires, he said, could be among the highest seen in recent years. That is a serious statement, and it is worth taking seriously, while remembering it describes a risk and a likelihood, not a certainty. There is a longer shadow here as well. Large fire years do not only burn forests and homes, they release great amounts of carbon into the air, which adds to the long-term warming that made the fires more likely in the first place. A severe fire season can feed the very warming that helped create it. This is one of the ways a single bad year can leave a mark that lasts beyond itself. The guidance for people in fire-prone regions is practical and calm. Clear dry brush and material from around buildings, know the local warning system and the evacuation routes. Have a plan to leave early before a fire is close rather than waiting. When smoke is heavy, stay indoors with windows shut and use a good mask if you must go out. These steps are familiar to anyone who has lived through a fire season, and they save lives. Fire is the sharpest of this year's hazards, but it is not the whole story. Across all these risks, drought and flood and fire and storm, the deciding factor is often not the hazard itself, but whether people saw it coming and got ready. That question of preparation is where the story turns more hopeful. After so many hazards, it is worth pausing on the most hopeful part of this whole story. The world can see this coming, and seeing it coming changes everything. Return for a moment to the 1870s, the historic event recalled earlier. The tragedy of that era was not only the drought, it was the surprise. People had no way to know the rains would fail across so many lands at once. There were no satellites watching the ocean, no models forecasting the season, no warnings to act on. The drought arrived unannounced, and by the time its effects were clear, it was too late to prepare. That is much of why the death toll was so vast. The contrast with today is the heart of the good news. This El Niño was spotted months in advance. Satellites tracked the warm water rising and the warm pulses marching east. Models projected its growth through the autumn. Agencies issued advisories and updated them month by month. The world has had a long warning, in detail, while there is still time to act. That single difference, the months of warning, is among the greatest advances in our ability to live with this pattern, and the warning is being used. During the recent strong El Niño a couple of years ago, the United Nations Food Agency took early action across at-risk regions before the worst of the drought and flooding arrived. They repaired and built irrigation systems where drought was forecast. They strengthened flood defences where heavy rain was coming. They gave cash to families so they could move out of harm's way ahead of floods. They handed out hardier, faster-growing seeds so farmers could adapt to the changed conditions. These are not dramatic rescues. They are quiet, early steps that prevent the worst before it happens. This kind of early action has a name among aid workers. They call it anticipatory action, which simply means acting on the forecast before the disaster strikes, rather than responding after. The logic is plain. A sandbag placed before the flood is worth far more than a rescue boat after it. A reservoir managed carefully before the drought saves more than food aid delivered once the crops have failed. The forecast turns the usual order around, letting help arrive ahead of the harm. For an individual or a family, the steps are simpler, but follow the same idea. The first step is to learn what the forecast means for your own region, because El Niño does different things in different places. Find out whether your area faces a drier or a wetter season, and prepare for that specific risk. Where drought is likely, save water and plan for a thin harvest. Where flooding is likely, clear drainage and know the higher ground. Where fire is likely, clear the brush and plan your exit. The right preparation depends entirely on where you are. The common thread in all of it is to act early and stay calm. Panic helps no one, and these events unfold over months, not minutes. There is time to prepare sensibly. Keep an eye on the official seasonal outlooks from your National Weather Service, which update regularly as the picture sharpens. Follow the guidance they give for your region. Treat the forecast as a gift of time, which is exactly what it is. It is also worth keeping the whole thing in proportion. El Niño is a natural pattern that has come and gone for thousands of years. The world has lived through many of these events, including very strong ones, and come through them. What is new this time is the warm background and the questions it raises, which is reason for attention and preparation, not for fear. The same tools that let us see this one coming let us soften its blow. Preparation answers the hazards we can foresee in the months just ahead, but this event has a longer tail, and understanding it means looking past this year into the next, when some of the largest effects are likely to arrive. One of the most important things to understand about this event is that its biggest effects may not arrive this year at all. They often come in the second year, and that is much of what the title meant by saying it is not over. The pattern of delay shows up again and again in these events. The ocean reaches its warmest point in late autumn or winter, but the largest push to global temperature tends to follow months later, well into the next year. The most severe Amazon fire risk lands the year after the peak, once the reduced rains have dried the forest. Many of the heaviest effects on weather around the world spread through the winter and into the year beyond. The event peaks in the ocean over one season, then keeps delivering its consequences for many months after. The reason for the lag is the slow nature of the systems El Niño moves. The ocean holds and releases heat slowly. The atmosphere takes time to respond to the shifted ocean, and the land takes longer still to dry out or to recover. A forest does not become flammable the day the rains fall short. It dries gradually over a season and into the next. A reservoir does not empty in a week. It draws down over months. So the chain of effects stretches out far behind the moment the ocean peaks. For this event, that means the months ahead are likely to bring the strongest part of the story, not the end of it. If the warming peaks late this year as forecast, then the deepest droughts, the worst fire risk, and the highest global temperatures may well fall in the following year. The event that was declared this June is not a single moment that has passed. It is the opening of a stretch that runs well into the next year. A climate scientist drew out this longer view directly. He suggested the effects might first show as sustained tropical and subtropical warmth through this summer and autumn, then progress to more pronounced heat waves in the middle latitudes beginning the following year. He described it as a step upward in the long climb of warming, the kind of jump seen repeatedly during strong El Niño events on a warming planet. The point is that the influence does not end when the ocean cools. It can echo forward. There is a genuine open question about how long that echo lasts, and the honest answer is that no one knows for certain. Some scientists have suggested a strong event now could help lock in elevated warmth for years. Others say it is more likely a one-year boost that fades as the ocean cools. One researcher cautioned plainly that with so few very strong events to study, and none on a world this warm, anyone claiming to know how long the effects will last is standing on thin ground. The The possibilities range from a brief spike to a longer step up, and the science cannot yet say which. What is not in doubt is the near-term direction. The event is still strengthening. It has not yet peaked. Its widest effects are still ahead. Whatever the long tail turns out to be, the coming year is the part to watch most closely, because that is when the ocean's stored warmth will be doing the most to the world. This is the plain meaning behind the phrase that it is not over. The warning was issued at the start of the story, not the end. The ocean is loaded, the forecast points up, and the months ahead will reveal how far it runs. Which leaves the final question, the one this whole report has been building toward. What do we actually know? What remains uncertain? And what should we watch for next? So where does this leave us? After the full picture, it is worth gathering the threads into a clear and honest summary, separating what is known from what is not. Here is what is known. El Niño returned to the Pacific in June, confirmed by forecasters and visible from space in the rising sea and the warm water marching east. It came on fast, faster than many expected, and by mid-year the Central Pacific had warmed well past the line that marks the event, into strong territory, and was still climbing. The atmosphere has responded, which makes it a true event with worldwide reach. The major forecasting centres agree it is likely to grow stronger and to peak late this year. All of that is settled. As much as anything in this science is settled, here is what makes it stand apart, stated once more plainly. A warming of this size has happened before. It has never happened on top of a planet this warm. Every strong El Niño in the modern record formed on a cooler Earth than the one we have now. This one is the first to arrive on the warmest background ever measured, and that combination is what no living person has witnessed. It is the reason scientists expect a real chance of record global heat this year or next, and the reason the familiar effects could bite harder than the textbook suggests. Here is what remains uncertain, and the uncertainty is real. No one can say yet exactly how strong the peak will be. The most likely outcome is a strong or very strong event, but whether it climbs to the rare extreme that some models suggest, the level last approached in the 1870s, is far from settled. The ocean could still stall, and because no event like this has formed on a world like this, the past is a less reliable guide than usual to exactly what it will do, region by region and month by month. The ocean signal is clear. The local translation carries wide error. Here is what to watch for next. Watch the monthly updates from the forecasting agencies, which sharpen the picture as the ocean shows its hand. Watch whether the Eastern Pacific catches up to the benchmark of 1997, since that will tell us much about the peak. Watch the regional outlooks for your own part of the world, because El Niño does different things in different places, and the right preparation depends on where you are. And watch the next year as closely as this one, because the largest effects of this event are likely to arrive after the ocean peaks, not before. The steadying truth runs underneath all of it. This is a natural pattern the world has weathered many times. What is different now is the warm background and the questions it raises, and the answer to those questions is attention and preparation, not fear. The same science that spotted this event months early gives the world time to get ready, time the 1870s never had. Used well, that time saves lives. The ocean is warm, it is still warming, and the story is only partway told. We will keep watching it, calmly and closely, and we will return as the picture sharpens. For now, that is where the Pacific stands. Thank you for listening, and we will see you in the next report.